Okay, so last week, or 2 weeks ago, we talked about water and the properties of water, and a question came up after we did the experiment. We had some instances where the little tie for the bread bag, it floated in the oil, in some people's oil. Okay, so that kind of brought up a question, and we're doing science here, so we're going to talk a little bit about the scientific method. So the first question to the scientific method, or the first part of the scientific message, is to make an observation, which we did. We observed that in 1 or 2 cases, it floated in the oil when we expected it to sink. Okay, so I kind of came up with a hypothesis, and so that's the kind of the next step of the scientific method. And in that hypothesis, it made me think about things like density and viscosity. So we're going to talk about density and viscosity today and how it relates to living things and why it's important. Okay? So before I did that though, I did a little experiment. You really can't see what's going on here, but I took 2 different types of oil. And in one type of oil it sank, and in the other type of oil it floated. Yeah. And so that really led me to the idea that the more viscous that the liquid is, it might be keeping that little thing from falling down, okay? So the things that we're going to talk about today, one of them is viscosity. And viscosity kind of relates to the fact that liquids can be really thick or they can be really thin. And when something is viscous, that means that it's a very thick solution and it's going to run really, really slow. Okay? We're also going to talk about density. And density refers to how much something weighs in relation to how much volume it has. Okay? So that's the first 2 things we're going to talk about. So when we talk about weight, you know, you could step on the scale and you weigh something. That's like your mass. That's how much pressure you put down on the earth. Okay? When we talk about volume, that means how much space something takes up. Okay? But if you notice on my little equation right there, that the weight is on the top and the volume's on the bottom. Meaning that something in the bottom, if it gets bigger, something is going to be less dense and it will have more of a tendency to float. Okay? So we're going to look at both viscosity and density here. So your supplies, if you have them with you, you should have 4 cups that are labeled and have colored solutions in them. You should have some blue Dawn dish soap, and you should also have some, corn syrup. Okay? I also put down some paper underneath, like I took a newspaper and put it underneath all of my solutions because it can get kind of messy if you spill things. Now you should have some sort of jar or cup or water bottle, but it has to be see-through so you can see what's going on inside of it. I just kept some old, I have a salsa jar and a peanut butter jar. If you use a water bottle, you do want to have the top of it cut off because you want to be able to pour into a wide mouth. If you're trying to pour into a little water bottle, it's really hard to get it to go down the sides and it's going to be really, really messy. Okay? Parents who made these solutions, or if the children helped with them, you probably noticed that corn syrup is a little on the sticky side. So we don't want to be all sticky all over the place. The other thing is, if you have your computer nearby your experiment, make sure you cover that computer or the tab, cover it up or move it away, because you don't want to spill any of these sticky solutions all over your mom and dad's keyboards and mess their computer up. Okay? All right. So, with these solutions, we're going to be pouring them into our jars. So I'm going to go ahead and I'm going to use my peanut butter jar because it might be something that you can see a little bit better. Okay? So the first thing that we're going to do is we're going to take the plain old corn syrup, not one of the solutions that you made, but the plain corn syrup, and we're going to pour it into the jar. there's not a certain amount, but keep in mind that you're going to have 6 different things that you're putting in your jar or your bottle. So when you put them in there, you want to put them in a way to where it goes maybe 1/6 of the way up. You don't want to fill it halfway and then not have room for the other things. But you want it to be full enough that you can actually see the layer, okay? So I'm going to go ahead and pour my corn syrup. And as you pour the corn syrup, I want you to notice how thick it is. Okay, and so we're just going to pour this in the bottom. We don't have to tilt it or anything. So I'm going, I don't know if you can see, I went about that far with it, okay? Now as I move it around, it's really thick. It's a very viscous liquid, okay? So when we talk about the relationship between these solutions, we're talking about density, okay? And we're talking about viscosity. But what we're going to try to do with these is see if we can layer these solutions and hopefully see the differences between them because they have different densities. And when you look at the density formula, the weight, so all of these weigh about the same. Okay, we're putting the same amount of solution in. But the thicker, more dense solutions are going to have a bigger number on top. So let's just, for example, if I were to say something has a density of 50 and its volume is 5, that's going to be a very, very, very thick, viscous, dense solution. On the other hand, the bigger the bottom of this gets, or the smaller the top gets, the lighter it's going to be, the less dense it's going to be, so it's going to be able to float on top. Okay? So we have the first solution in, all right? And I didn't add any color to this one because I just wanted it to remain kind of clear. Now, you should have a cup that's labeled number 1. Now, when you made the solution, cup number 1 should have 75% corn syrup and 25% water, or it's 3/4 of a cup to 1/4 cup of water. So this is still a relatively viscous, relatively dense solution. Now when you start adding them, I want you to hold your cup at your jar that you're putting it at an angle, and then I want you to pour the solution down the side of the jar. This is where I said it might get a little bit messy. And as we're pouring, we're hoping. Now remember, this is a science experiment. Not everything always works out perfectly, but it looks like it's working. So I'm going to keep pouring to get a kind of a similar size. Okay? So in mine so far, I have a separation layer between the original corn syrup and the red solution. Okay? So hopefully everybody got their second liquid in. Did you guys get them in? Yeah? Okay. All right. So here's where we're going to not go to it. We're not going to do the next prepared liquid first. We're going to do the soap. Okay? And the reason I had you get Dawn Blue dish soap is because it has a certain density, plus it has the color blue, so we didn't have to color it with anything. Okay, so we're going to do the same thing, and if you have a lid on it, you can go ahead and take that lid off so it's easier to pour, but you're going to do the same thing. You're going to hold it in an angle and pour the soap down the side. And we're going to keep pouring till we get kind of a nice, another even layer. You might see some purple developing between the two colors. That's okay. Okay, but I have a distinct clear layer, I have a distinct red layer, and I have a distinct blue layer. Is that what you guys got? Do you have that so far? All right. Okay, so now we're going to go back to our solutions. Now I want you to take solution number 2. Now you're going to pour this in and we might see something different happening or we might see something the same. So once again, just slowly pour it down the side. Okay, you may not be able to see what's happening because the green and the blue look similar. But in my jar, my green solution is more dense than my soap. So the green solution is actually sliding underneath the blue solution. Okay, and the blue is actually moving up. Okay, that's because the green is more dense than the blue. I'm going to add a little bit more to kind of keep them even. Oh no, I almost spilled my soap. Hope you guys don't spill anything. All right, it's hard to see because the green and the blue are similar, but that might change in just a second. All right, I almost just had an enormous mess over here. Don't do what I did. Okay, move the stuff out of the way after you use it so you don't spill it. All right, so that was number 2. So now let's try solution number 3. And we're going to do the same thing. We're going to pour it down the side. I don't know about you, but my jar's getting kind of heavy. I guess I should work out more. All right. If yours is anything like mine, this orangish solution is now starting to go underneath the blue also. Which is actually kind of cool because they're separating themselves even though we were trying to put them on top of each other. So I hope you guys did the same colors that I did. All right. But I have the clear on the yellowish, the corn syrup on the bottom. Then I have a red layer, I have a green layer, I have an orange layer, and then I have the blue layer. Okay? Now, I'm not sure if there's different degrees of density in the Blue Dawn soaps, or if you guys got the same layering than I did. Give me a thumbs up if you got the same layering I did. Okay, all I can see is myself. All right? Thumbs down if you did not. Okay, so if the, let's see, I don't know who the little person is on the bottom. All I can see is the top of your head. I don't know who you are. If you gave me a thumbs down, will you hold up your jar and show me what you got? No? Okay, now he's gone. All right, so we're gonna do one more layer. Oh, there you are. Okay. I can't see what's going on. All right, so we're gonna do one more layer. We're gonna do number 4. And on this one, be very careful to really slowly pour it in there. Okay. All right, so I'm starting to get the yellow layer on top. I'm just going to keep pouring it until it's about the same size as the other layers. Okay. So I have the kind of clear layer on the bottom, then I have red, then I have green, then I have orange, then I have blue, then I have yellow. Now as you look at those, the number 4, the yellow, was just pure water with nothing in it. Okay, so it's obviously the least dense because there's nothing in it. So it would be something like 0 over whatever. Okay, each of the other solutions that we made in the cups had varying degrees or percentages of corn syrup, so they were a little bit more dense. At the very bottom was, of course, the corn syrup, the 100% corn syrup. Now, did you guys bring some items with you to drop into your solutions? Okay, now I want you to take your items that you have. I just found some random things around the house. I have a little bead, I have a jewel, I have a Skittle, a tack, and some different things. My fingers are stuck together with corn syrup. Are your guys stuck together? All right, so look at the items that you have that you brought to put into your jar. All right, I want you to put them in order from left to right of which ones you think are going to sink and go further down in the solutions, and on the right you're going to have ones that you think are going to float. Okay, so you're going to kind of hypothesize what you think will sink or float, or maybe stop halfway, you know, maybe it'll go to the blue layer and stop. Okay, so you want to look at them and think, well, do they seem heavier or do they seem like their volume? So if they have a high volume and a low weight, they might float a little bit. But kind of predict, we're going to make a prediction of how we think they're going to go. All right. Now with science, when you make a prediction, if it's not right, that's okay, because that's what science is about. It's all about learning. So we're just predicting based on what we know about density in these different solutions, how it might work. So let's go ahead and start with the left one that you have there and drop it in there, and let's see if we can observe how far down it goes in the jar. Oh. So the first one I dropped in there stopped in the blue layer, so it stopped in layer number 2. I'm going to drop something else in, so go ahead and just one at a time drop each of your items in there. Well, that one floated on top. Ah. I am so sticky, I can't touch anything. All right, so far everything's not going very far for me. I'm gonna try that. Oh, there we go. All right, I put in a tack, and it sunk all the way down to the red layer. So that's a pretty dense object. So a tack is made of metal and things like that. So metals are pretty dense. They're pretty heavy. Okay. I have this little part of a zip tie. It's kind of sinking right to the blue. A lot of things are started stopping at the blue. Now I have this Skittle. Let's see how heavy, how dense this Skittle is. It's all made of sugar. Think sugar's dense? All right. So I'm gonna drop it in there. Whoa. Yeah, it's going all the way down to the bottom. So obviously it's a pretty dense object. So did you get all your items dropped in there? Okay. I'll wait. I'm really stuck together. All right. So give me your thumbs up when you have them all in there. All right. I tell you what, my fingers are literally stuck in the Okay. So now we're going to talk about what this all means. Okay? So last time we did the properties of water and we talked about surface tension and we even mentioned density. If you remember, last time we talked about a pond. Okay, so here's some water. And we talked about how the little fish and plants in the water, if water were to freeze from the bottom up, that they would all die, right? But we talked about how when the ice is formed, it separates, making it less dense. So it increases its volume without increasing its weight. So these little fishies are surviving. Another thing about fish is fish have this thing inside of them called a swim bladder. Okay? And so when fish want to swim down, they kind of puff everything out of the swim bladder and it deflates. So if you've ever been swimming, or when you were kind of little, your parents may have put like a life vest on you, or if you go out in the lake, you might wear a life vest, or maybe you had those water wings that you wore. Those things that you wear when you're in a pool or out on a boat, when you fall in the water, it increases your volume, your space that you're taking up without increasing your weight, okay? So the fish does the same thing with their swim bladder. They'll increase the volume, and they'll be able to go higher in the water and float, and then they'll deflate it to go lower in the water, okay? So the properties of density, you know, are important in ecosystems and things like that, but we also talked about viscosity. How viscous, how thick a liquid is. So I hope you guys are not intimidated by my wonderful art skills, okay? All right. So I'm gonna draw you or me, whoever. So here's a person. Okay, their arms are not the same length. Okay, so let's at least make their neck the same. All right. So that person has a heart, and their heart is pumping blood. Okay? And it pumps the blood all through their body. Well, when a person has real viscous blood, it's hard to push the blood to the body. Okay? What would cause a person's her blood to be viscous would be things like dehydration, or if you hear about people that have high blood pressure, let's go to dehydration first. Last time we talked about water being important, so one of the reasons that water is important is it keeps you hydrated. Actually, it keeps your liquids flowing in your body, okay? So that your heart, oh my gosh, that's awful. So that your heart can pump it. If it gets real thick, your heart has to work super hard to try to get it to the rest of your body, okay? When somebody has high blood pressure, it can be due to a lot of reasons, but one of the things that can cause it is their ions are messed up, and they can't get the right amount of fluid levels, and so their kidneys have to work hard and their heart has to work hard because of the viscosity, the thickness of the blood, okay? So that's the end of our density viscosity experiment. Hopefully we answered the question about why things floated last week when we thought they were going to sink. So obviously some of the oils have a little bit of different viscosity than we thought they would. Okay, wow, the lights just came on. And the importance of these things in your body, but also in our little fish pond there, okay? So do you guys have any questions? If you have any, you can type them into the comment section, and I can answer them for you. But did you guys enjoy it? There's me. Eat the Skittle now. No. First of all, I'm not going to dig it out of there, okay? Maybe that could be your challenge in your home to see who will eat this. Oh, you guys didn't do a Skittle. Okay, I'm not going to eat it, but thank you for asking. All right, do you have any questions about density or water or why it's important? Oh, is there any more? Oh, he's making the comments bigger. Maybe not. Oh, I still can't see them. Just go ahead and make them small again. All right, well that was it for today's experiment, and we'll have a new one in another 2 weeks. Invite your friends to come and join you. All right? Have a good day. Wash your hands because mine are sticky.
Bye, Mary.
Bye.
Thank you so much.
Thank you.
Yeah.
Bye. You're welcome. Oh, man. I just better stop the video.